Okay, hello everyone. Good morning. So we meet again, and some of I think new faces. Let me start the introduction. Okay, so the first class is supposed to be the introductions. I will explain a little bit about the syllabus. Uh, if you have uh, if you have your smartphone, you can scan the QR code, and you will see the same presentation as I did in the front of you. Okay. So okay. Okay, so yeah, that's my name. Imanadi Purnama. I was also a student back then when I was studying master and PhD. Okay. So I know how it feels in the classroom. Although I'm not really doing bachelor in NTST. Okay, that's a really short introduction. Okay, I would like to know. Okay, I would like to know how many of you passing the course and didn't make it, because the course for the calculus 2 will be more related to calculus 1, because we are going to use the same method, the same techniques that taken from the calculus 1. So I would like to know the numbers. And so I have background, and I have background, so I can, when I teach, I know how many things that I need to review. Okay, barely pass. Okay, barely pass is good for calculus. Calculus like 4 credits. Okay, 14, good score. For those of you who take the calculus 1, are you happy with the last score, the final score? Are you happy? No? Okay. Okay. Okay, I think that's pretty much. Okay, didn't make it. Only one. Okay. If you can just if you haven't taken, you can also put the didn't make it, because it's considered you haven't really learned calculus. Okay. And don't worry, I wouldn't know your name from here, and it wouldn't be publicized to others as well. But I think it's quite descriptive. Okay. Okay. So what we need to prepare is basically you need to review a lot calculus 1 notes, especially the basic techniques such as the in derivatives you have the implicit, right? And in integral there are many techniques, substitutions, the integration by parts, and so on and so forth. In calculus 2 we are going to use similar techniques, so I would like you to review a lot. If I have time, I will take a short review in the class, but I will not review all, but only the one that is really connected to the chapter. Okay. Yeah, I think manage your time wisely. I believe this is pretty common and pretty general to all of subject if you study other subject as well. Tutoring, I would like to advise you to take tutor. I think last semester some of you take tutors, right? And for local student, you can search your senior and maybe asking some of them to be your tutors, and I think they can apply becoming official tutor to the learning center. Okay. And for the international student, you can also look for your senior. I think one senior already officially become your tutor, but if you need more, and you have more to discuss, you can talk to me and we can find another tutor. Okay, tutoring and practice makes habit. sometimes people say practice makes perfect, but I think not perfect, because practice is not necessarily makes you smarter, but it makes your habit becomes attached to you. Okay? Because if you are not making this as a habit, I think you'll be having difficulty on recognizing, especially if you are, because calculus usually you are given as a set of problems, and if you are not recognizing those problems, then even though you know the techniques, but you don't know how to use it and how to visualize in a solutions, and then that will be a pretty difficult to do. Okay, so I think practice will help you. Okay. Although I'm not suggesting like you should like learn every day, like most of the time you learn. No, makes your learning smarter. Okay, so you need to manage your time wisely, okay, and study smarter. Okay, usually people say, oh, study hard, study hard. No, study smart. Hard sometimes makes you feel maybe the outcomes sometimes depressed, okay, if you study hard and then you didn't have the really good result and outcome. But study smart, you know yourself, you know your limit, right? In calculus we learn limit. You know your own limit, and you know how to learn. Okay? You know which method are perfect for you. Okay? And I believe you are already mature enough to know which method and which subject that you are really suitable for. Okay? So that's, I think, it's a little bit tips and preparations along the learning or along the semester. I will also give you another advice and maybe some tips to help. Okay. Okay, the same textbook. This is the James Stewart 9th edition calculus. We're still using the same textbook. Okay. I think some of you maybe prefer the. There are other editions that is early transcendentals. The content still the same, but I think that one is easy to understand. And this one is more heavy, like a lot of words, but the same content. Okay, same content. And I think if you find like in the website, there's a lot of learning website, or sometimes they provide like step-by-step solutions. Sometimes it's good, sometimes it's bad. Okay? It's good if you understand. It's bad if you don't understand, right? If you like, they give you like, oh, this is the solution. If you just read and just copy that solutions, that's bad. But you need to understand what you are copying. Okay. Although I must admit that if I give you homework, I think some of you will copying the others. For me, that's okay if you understand. But if you are just copying like blindly and just following, then it's pretty bad. It's not helping you in the exam. Okay? So homework is, I believe, one way to help you to better yourself, at least for practicing. Okay? Okay? And other learning that usually I gave, I forgot to put here. I think I'll write in the board. Okay, I think these two, I think for engineering students, especially who would like to involve more in mathematics formula, those two are good source for Wolfram Alpha. It's a computational program for basically solve anything. Okay? So you can you can simply write anything related to science, technology, or other subject as well. I think they have a computational algorithm for other subjects like socials or maybe history as well. Okay, and the GeoGebra is a source for creating a graph. Okay? Both are cloud-based, so you can just go to the website, or maybe you could Google it, and there will be, I think, the number one, and you can click. Basically, you can try Wolfram Alpha. You can write anything. You can write formula. I think they are preparing the mathematics notation. So you can just select your notations like integration or derivative. They have the notations. Okay. So sometimes I also check solutions through the Wolfram Alpha, but they will give you, usually they will give you the direct solution, the exact solution. Sometimes the solutions might be a little bit different because of maybe there will be some method that has like alternate solutions. I think the Wolfram Alpha also provide alternate solution, but yeah, but because they are really like a calculator, so it's giving you like an exact, like if it's in decimals, it's decimals numbers, for example. Yeah, and GeoGebra is for graphing. Okay. Or I think if you want to like dive in more, I think there are trends nowadays using ChatGPT. You can also try that. I have tried and I was surprised it's really good. It's really good. But sometimes if it's the server is full and you're still in free version, you need to wait for a few moment. And the prompt when you write something, if it is too long, the prompt maybe takes times. But if you are like asking like a simple answer, looking for a simple answer, it was really good, really fast. But sometimes if you wrote illogically, not in a good way for the computers to think, for the machine to think, sometimes they will give you not really like the one that is expected. Okay, you could try that as well, like ChatGPT. But ChatGPT is, I think, it's too broad. Okay, sometimes too broad. So I just would like to share with you these two. Okay, the Wolfram Alpha and the GeoGebra. There are also other graphing for mathematics as well, like Desmos. You can also try. You can also try. It's, I think same function. So GeoGebra and Desmos. And in GeoGebra, you can see that it will also give you the learning source. Okay. So some people, or maybe some teacher in GeoGebra, they prepared like some special segments, special sections to learn. Like maybe in calculus, there are some topics perhaps related for example, the first chapter you learn is limit, right? And some people in the GeoGebra, they provide like its sections with the visualized graphics for limit, how to understand limit. Okay. You can like find anything, like you can type in any sections in calculus in GeoGebra, and maybe you'll find something. And some of the learning source is really good. You can also make one, but yeah, if you have time, okay, if you have time to learn how to prepare. Okay, okay, that's the reference. The scoring, I think a little bit similar to last semester. So quiz 25, attendance homework is 10, participation is 5, TA is 10, midterm 20, final 30. So final and midterm, can you see clearly behind? Maybe make a little bit darker in the front. Okay, I think that's. So if you get midterm and final, it's 50, right? And TA, if you attend TA regularly, it's already 60. Okay, it's already 60. Or if you are maybe not really confident in this too, this other here is 50. Okay. So if you take 10, 5, 10, it's 25. Okay. So you could predict how much percent like you can get like from this 50 to make up your attendance, to make up your 25. So this is 25, right? And from here maybe you get 25. Okay. So you already get 50. So to get like 70, so you just could have like 20 from here. So 50, 20, 70, right? So I believe this is also how to optimize your learning, okay? Because sometimes you need to make sacrifice, right? Because I believe not all subjects, like you take in, especially a bachelor's, you need to manage your course wisely. Okay? If you are not able to deal with all the course at the same time, at the same semester, you need to make priority which course that I believe I can take this one. Okay? If you are taking like, oh, I can do it all, it's good if you are able to do that, but I believe some students will feel, oh, probably I need to make sacrifice. Maybe you will prioritize another subject. That's okay. So how to make prioritize, you can also see from here. Okay, which one that I think I will prioritize, maybe in the midterm, maybe in the quiz. Okay. Okay, and you can also compare with other course as well. Okay? The scoring system, how you can manage yourself. Okay? And this course supposed to be, I believe for most of the basic course and fundamentals, we need like 18 weeks. Like we are going to move to, I think June, right? June, early June for the finals. Yeah, we are going to see later on. Okay. Okay, so this is our calendar. It's supposed to be, we are going to have introduction. This is introduction and a little bit of introduction of chapter 8. This is actually in my regular classes before. The arc length is in the calculus 1, but we are not able to finish it on time. So I'm going to finish this subject chapter 8 within this week. Okay, within this week. So arc length and the surface revolution. And then TA class every Friday. Friday 3:20, right? 3:20. Yeah, so that's February. Okay, we move to March. And this is all personally, this is my optimistic route, okay, optimistic plan. If maybe some subject needs to be switched, we can adjust later on. Okay. Like for example, I'm preparing like a first quiz within this week, this second week of March. But this for quiz, it can be switched like here or maybe here, okay. or maybe early, okay, maybe early. And we can adjust the content for the quiz, which part that we need to take. Okay. So March we move to chapter 10. Okay. So calculus 2 basically start from chapter 10 to chapter 15. No chapter 9. I'm skipping chapter 9 because chapter 9 is related to engineering of math. Because you will learn all the things in chapter 9 if you take engineering math later. It's the same content. So I'm skipping chapter 9. So chapter 10 and then chapter 11, sequence series. And then it's quite a lot, the content in chapter 11, so I need more time here. After finishing chapter 11, another quiz. And then we move to vectors. And then And then I think this is holiday, right? And then move to still vectors, finishing the last part on vectors. And for vectors, because I believe you have learned before the basic in physics, so I would like just to, the first part is like a short review, what is vectors and so on and so forth. The main idea of vectors in calculus mainly starts from this part, the line, planes, and quadratic surface. That's the calculus, like I will emphasize this part a lot. Okay. And then we move to vector function. And this is basically, I wrote this like, okay, we have like 1 day to finish all, because this is a really short chapter. If you read the textbook, it's really short, okay? It's really short. Supposed to be the midterm here. The midterm is from the chapter 8 until the vectors. Okay? But if not, maybe 8 to 11. Okay? Maybe 8 to 11. The vectors maybe will comprise in a quiz. Okay? Maybe in a quiz. Because if I compile a lot of chapter, maybe the midterm will be too much content. Okay? So maybe I will shorten the content. And then we move to, so this is April, move to the partial derivative. Okay? The partial derivative, basically the main dishes in calculus 2. So the main part is from chapter 14 and chapter 15. Those two last part is basically the main content. Like before it's like this, like a appetizer. So the main content is here. Main will be very difficult. Okay, so that partial derivatives. And then on May we move to multiple integral. Another quiz. I'm preparing 3 quizzes, but perhaps we can have like 4. And we can see the average later, and we can decide whether you need to take another quiz or not. And then, yeah, multiple integrals. And maybe if well, it depends on how we progress. Maybe I will skip a little part in the multiple integral. Or maybe I will give you a class, but 1 or 2, a little bit content, maybe not really in the final. So I will let you know later which part that you need to emphasize. Okay, and then my plan is having a final here. Well, we can also have final in Wednesday, but I think we will have difficulty Wednesday morning, right? So I think Thursday better choice. Okay, last day class is here. Okay. So if we finish early for this last part here, this Thursday we can have overview or maybe review and exercise. But if not, then this will be last class on multiple integrals. The 15.9 is, I think, if I'm not mistaken, it's about the Jacobian techniques. Okay. Okay. If you have any suggestion, please write first here. Okay. You can submit multiple times. You need to also submit your student ID, okay, so I know which student is coming in the first class. Okay. Okay. If you haven't scanned QR code, you can use that website, www.menti.com, and you can use the number 2744-6691. Okay, if you have any suggestions, if you have any comments, feedbacks, maybe based on your experience learning from the first calculus. Okay. Who is writing that? Okay. Oh, there are F student. Which one? Oh, exchange, right? Is there any exchange? Other? Is there any other? Okay. But do you need to take this course, or like this is a requirement?
It is required in my university.
Oh, okay. But have you learned like the calculus 1 before? I have. Okay. Good. Okay, if you write anything, comments. What do you think last semester for the one who take the calculus 1? What do you think? Okay, good. Or anything to improve?
I think like the integral part is kind of fast.
Ah, okay, okay. Okay. Perhaps that one we can have more review later on when we learn, especially in the last part, the chapter 15. Okay. Yeah, because I think we like discussed too much like in the first half, so the second half is like, whoa,
Yeah.
right? Yeah. I feel it too, like too rush on the last part. That's why I decided to adjust like the question in the finals. It's supposed not to be that question, so I changed a lot of questions. Okay. Okay. Would like to move on to this. Okay. Our usual board. Okay. So I would like to start with the chapter 8. This is called the arc length. Okay. Let me draw a random curve. Okay. Let me just draw like that. Okay. Okay, imagine that like you have a curve randomly, or maybe to make it easy, maybe start with a circle. Start with a circle. So see the circle and this random curve. Okay. And before the circle, if you would like to know, like the length, okay, the length. I think for the circle, it's quite easy if you know the radius or the diameter, right? But if you have like a random curve like this, can you measure the length? Well, if it is like a wire or like a rubber, you can stretch and then you can measure easily, right? Well, that's a good way to think. If you have the if it's stretchy, you can stretch and then measure that when it's straight, right? So imagine this is straight, or that rubber. Imagine you put some, like you fold some. I didn't bring anything. I don't know. Okay. So if you like folding a little bit, or if I say to measure the like the circle here, maybe I would like to have like divide this into several points. Okay, and then connect all the points there. So all the points are connected. Well, in terms of approximations, well, we just have some space here, right? So the more we have the dots, the more we can approximate the circle, right? Now the same thing with the curve. Same thing with the curve. If we can like slice this curve, okay, like slice, I will just do this randomly. Just put these dots everywhere in the curve, along the curve, and then connect all the point. Okay, so connect all. And I think this is pretty good. So we can have, or approximately, we can have the length, like the measurement of length. Now, if we are in the x-axis, or let me just use the picture that I have prepared here. Okay, so let me just showing you the I think we need to just make it small here. Okay. Now if we let some points for some dots here. Let's say we start from A and ends up on B, and that is the range that we are going to measure. So we want to measure this curve from x equal A to x equal B. Okay. And let's say we are going to let this point, it's called pi, and it's pi minus 1. This is just to let you know that we are going to use this as our formulation. So for every point that is in between A and B, we can write the length, okay? The length, okay? So precisely this length, okay, let me make clear. So this length, the green one here, okay? Okay, that green one is, let's say, L, or let me write the length of curve y equal f of x from A to B is equals L limit as n larger it is the sum of the pi minus 1 pi. This means distance, okay? Distance. So how to read this is the summations means you're going to take additions, right? So this means, okay, this means every distance that has segmented like this, okay? So every part here, for example, start from P0, P1, get that distance, okay? And then P1, P2, P2 is supposed to be P3, and then P3, P4, P4, P5 until like Pn. Okay, n can be any numbers, and we imagine n is really large. Like we elaborate before that when you have n in large number, when we draw a circle and we slice the circle like with many points, we can approximate almost the exact numbers, right? We can approximate. So the same thing with the this arc length. Okay? So this is what we call the arc length, so length of the curve. So we are going to add all the distance that is segmented. Okay? That's the idea. Okay? How we measure the length. Okay. And to make it smooth, because if you see, if we have just like 1, 2, 3, 4, 5, 6, 7. If we have just like this 8 points here, the dots, our approximation is a little bit rough, right? If we want to make it smooth, like our curve, we need to make it many points. Okay? That's why we are going to have this n, okay? Going to be larger. And how do we know the distance? You see, this is like a hypotenuse in triangle. If we know the distance x and this delta here, delta y and delta x, we will know this part, right? Okay. So from here, yeah, I think I can wait for you if you want to take notes for this one. Okay, so first we can let delta x as a xi minus xi minus 1, and we let delta y as yi minus yi minus 1. So from this delta x and delta y, we could figure it. We could measure the distance, okay, from pi minus 1 to pi. Okay, I will give you the whole conclusions. Okay, so here, if you have the textbook, you can read that part. Okay. So we could have the let me start from here. Okay. So we could have this Pythagorean, okay, this Pythagorean conclusions, and then if you remember our theorem in the previous plus 1, the mean value theorem. The mean value theorem, if you remember, this is basically just a linear equations, right? You can imagine like this is y, this is the gradient m, this is x minus x1, right? Or if you prefer writing the gradient is equal delta y over delta x. Okay? So the gradient we know is the first derivative at that point. So this is actually just to show you that there will be a number. Okay, there will be a number. We call this number is xi with the asterisk. Okay, this number is in between the xi minus 1 and xi. Okay. And we could rewrite this, and or if you would like to start with the gradient is delta y delta x. Okay, of course it's approximately, right, and this will be f prime. If you would like to write with a first, it's okay. This is y, or maybe if you would like to write with xi, it's okay. Let's start from here, and then we know that the y is actually a function of x, so we could rewrite y as a f of x, and we could have this, and then from here we go back to our Pythagorean, and we change all of the y here, so we have the delta y is the f prime delta x. Okay. And then we solve this, factor out the delta x. Okay, factor out the delta x. So factor out the delta x squared. So delta x squared becomes delta x. So basically you can imagine you can divide by delta x squared, but divide by delta x squared. So delta x going outside, and we have the square root 1 plus f prime x squared. So by definitions, then the limit for L, okay, so limit as n larger is going to be the sum of the distance, the segment, and the segment is defined by this formula, and we have this results. Okay. And by the definitions, limit and sum is integral, right? Okay. If you remember, it's integral. So if we define this from a to b, then this will be the integral from a to b of this, and this will be dx. So this expression becomes this. So this expression is really saying that we are going to measure the length of the curve, the f of x, the curve, from a to b. Which one? Here? Yeah, I think this. Right. Okay. Okay, if you have problem to understand the mean value theorem here, I will have another another perspective how to get this formula easily, okay, without like really looking into all this stuff here. Because the important thing is we know the conclusion is one. But how we start that formula is from a curve. We cut the curve and we connect all the points that is on our slice. We cut all the points. And basically when you plus some in a summation system like this, you have the additional formulation inside, and you have limit. That limit is going to be approaching infinity. Basically, that is integral definition, right? So maybe any questions before? And if you have any questions, you can raise your hand. Okay. Yeah, and I also need to mention that every class I try to record all the lecture notes. So every time we finish the class, I will upload and I will post the information on Moodle, like in the calculus one. Okay, now yeah, we can simplify it. This is the conclusions. Okay, the conclusions. And you need to emphasize that the functions need to be continuous. Okay? The function need to be continuous. Okay? And the f prime also need to be continuous. If not continuous, you cannot really measure, right? You cannot measure the length. Now I would like to give you another perspective, okay? How to see this arc length in more intuitive way. Okay. Okay. Or maybe have a break first. Okay. Okay, let's have a break. Okay, we back to class. I forgot to mention, you can email me at this email or the other email as well, but I prefer this one. I will respond faster usually if you email me with this one, with the GApps NTSC EduTW. Or if you would like, you can also chat through Moodle. Yeah, I think that's also okay. Okay, now back to this curve here. So let me just give you this randomly simplified curve like this. Now, to let you make a good visualizations on arc length and how to have the good conclusions, the same conclusion as we proceed before. Okay, let me start with this. Okay, and let's just imagine. Okay, imagine. Usually we are going to take like segments, right? And we cut and then we plus all the segments. So let's just take one segment, small segments. Okay. Let's take the small segments here. Okay, let's take this segment here with the red color. Okay, and let's name this as DL. Okay, or any DS. It's okay. So let me just write with DL. Okay, and imagine that DL is really small. Okay, I draw like this much so that you can see from behind. And then what we are going to do is we are going to set a triangle. Okay. So dl here, and we have a good triangle like that, a right triangle. And we name this dy and dx. This denotes that d is really, really small, okay? Really, really small in terms of calculus. Usually d is used for something that is really small, right? Okay. Now we start with the hypotenuse. So let dl is equal okay. And then similar from before, we could let the dx squared, okay, factor out. So we could, let me just write dx squared, and let me write this dx squared multiply with dy over dx and then square. Okay, same thing, right? Okay, let's factor out this dx. Then you will have dl, let me write it down here, is dx square root 1 plus dy over dx squared. Okay? Remember that this is dl. We want to know the whole thing in L. Okay? So we take integrations both sides. Okay. Or let me write here to make it clear. So dl, let me write square root first. 1 plus okay, and then we take integrations. Let's say we take integrations from a to b, from here, from a to b. And let's take that. And in our definitions, let the L is integrations from a to b of the dl. Okay, so we can have this as L. And this will be the integration from a to b, 1 plus dy over dx squared dx. Okay, or dy over dx, we can say that is our first derivative, right? Okay, this is another approach that we can take. Of course, this is not official definition, but this is a good way to think. Okay, this is a good way to think how we get the formulations. Okay. I think if you just let, so if you forget what is arc length, so you can draw a random curve, like easy curve like this, take some small line, make a triangle, make a hypotenuse formula, and then you can see from this part, you can practically play with this and then make it into this part. Okay? But it's not always dy over dx. It can be also dx over dy. Okay? So we can have dx here or dy. Depends. Okay? Depends on how we understand the questions. Okay? Sometimes most of the questions can be understood from this part. But if the range is in y, then we need to operate with dy. So let me write here that it's not always, it can be also L is, let's use C and D and perhaps using G prime Y and then dy. So it depends on the curve, depends on the questions, okay, which part that we are going to use. For most cases, basically we can use the dx, but sometimes maybe there's a few questions that you need to use dy. Okay. Any questions? Okay. So far, so good. Okay. I think to get this formula and utilize this formula is easy. I mean, up until plugging the information here, what you need to find is the first derivative, put here, and then solve the integration. The difficult part is to solve the integrations. You need to take the techniques from calculus 1. So they do not maybe not remember calculus 1, maybe a little bit difficult. I think I will give you one or two example, or maybe one example first, and we can review tomorrow. Okay. Okay, let me give you another new page. So example. Find exact length of the curve. This is y equal 2 over 3x with power of 3 over 2 from 0 to from, yeah. Okay, this is A. Let me check the other one. Okay, the other one is y equal x cubed over 3 plus 1 over 4x from 1 to 2. Okay, 2 questions. So with very direct questions, just asking the exact length of the curve, meaning the arc length. This is the formula. This is the A and B, right? And the first thing you can do is find the derivative, right? Find the derivative and plug it into the the previous formula. Okay. I hope you're still familiar with how to do the derivative, right? Okay. Yeah, so calculus 2, because the calculus 1 is like it's inherent in calculus 2, so naturally will be more tough. Okay. Okay, let me take some space here. Okay. Okay, for the first one, I think I can get on with this. Find the first derivative. So this will be x, and 3 over 2 minus 1 is half, so we can write this just 1 over 2, like that. And then we can write the formulations like step by step. We can write this first. So 1 plus x with power of half squared, it becomes just x. So the L is just integration from 0 to 2 square root of 1 plus x. And then the x. Okay, how to integrate this? I think it's easily can be substituted, but I think because just 1 plus x, we can just assume that 1 plus x is just some variables, right? So we can make this into, let's just assume and make this like that, right? And then just make this 1 plus x like regular variable, or if you would like to make it more smooth, maybe we can just make it into like a, like that. So the x is the a. Or maybe just direct approach, okay? Direct approach, just directly integrate. So directly integrate, this will be 2 over 3, 1 plus x. Half plus 1 is 3 over 2, right? 3 over 2. And then evaluate from 0 to 2. So if we put 2 plus 1 is 3. So 2 over 3. This will be 3 with power of 3 over 2 minus 1 with power of 3 over 2. If you would like to simplify again this part, this will be 3 square root of 3. This is 1, right? Then we can have 2 square root of 3 minus 2 over 3. Okay. You can also use substitutions like I made before. You can make this, and dA is equal dx. And for x equal 0, a equal 1. And for x equal 2, a equal 3. So the new integrations become 1 to 3 a dA. The same, I think the same results. Is it scary? So, right? So, right? No, not too much. I hope not too much. Because if it's too much, I don't know how to say. This is one of the easiest example.
I think something I'll give back to you.
Hmm?
Something last semester
Oh.
I learned, I'll give back to you.
Okay. Oh, really? So nothing here?
Yeah.
Okay. So I give something, you return back to me, right? Okay. Okay, the last part here is the same way with this, but we just take substitutions. This part I'm doing it directly because it's just 1 plus x, so I can just integrate directly. Right? But if not sure, then you can just substitute and make it more simplified in the equation, and then this is easily to integrate also. Oh, forget the half. Okay. Forget the half here. Let me write more clearly. So a half the a. Okay, if you would like to solve this, so 2 over 3a, 3 over 2 from 1 to 3. And basically the same thing, 3, 3, 2, minus 3, 2. And we back to the same conclusions, right? Okay. Okay, number B. Is the difficulty is increasing. Okay, difficulty is increasing. But the idea is still the same. What we need to find first for this part, derivative, right? So derive is x cubed. So x cubed becomes 3 goes here. Cancel, it becomes x squared. 1 over 4x become minus, right? 1 over 4 x squared, right? If not, then you can make this goes up like minus 1 and then do the derivative. Okay. I think that's also okay. But if you know, like familiar with the subject, you can directly write. So you can directly write this as, you can write the derivative like with y prime or dy over dx. That's the same thing for me. So it's okay. So 3, so this will be x squared, right? And this will be or maybe if you feel not sure, if we take the 1 over x like this, we could think this as x with power of -1, right? So we take this -1 goes into the front, so negative x, and then negative -1, so -2, right? So we could say this is 1 over x squared. That's why it's become negative and with 1 over x squared. 4 is just a constant, so we just write again in the derivative here, right? Okay, but it's not over yet. We need to make it into our arc length formula, but let me just write one by one. So let me just squared and then plus 1. Okay, so 1 plus the whole thing, x squared minus squared, like that. Okay, now it's x squared and then squared. Okay, but it's still in this square, so you should be able to do this. Okay, I hope it's not too scary. So x squared x with 4. Okay, you just write it slowly but sure. Okay, 1 plus, this is x with power of 4, right? And then if we multiply for the next the next variable here, we need to multiply this. So it's negative 1 over 4 multiplied by 2 is negative 1 over 2, right? Negative 1 over 2. Negative 1 over 2. And then the last part is plus 1 over 16x and then with power of 4. Okay, now I think we can cancel 1 with negative half, so it's become plus, right? So it's become x with power of 4 plus half plus okay. Now this is my tips. Sometimes when you do the arc length formulation and you compute the derivative and then you're trying to deal with this formula, sometimes you ended up with this kind of formula. You have like with power of 4. But if you look back, what we did before, it was x squared minus 1 over 4x squared, and we squared this. We did something here, and eventually it's ended up with this. Sometimes, maybe, we could make this back into this with a bracket squared. Okay. And I think we can, right? It's just the same thing, but it's just a plus, right? Okay. And some of the cases, that is mostly happen in arc length when you find this. So if you feel like you find this and then you get the formulation in the arc length, you have to square root this, and you feel like, oh, how to do this, right? So sometimes this is going to happen, and we can make this into like x squared plus 1 over 4 x squared squared. And it's nicely done, and then it will cancel with the square root later, right? So we can take the arc length. Let me just write. L is, what is AB? Is 1 to 2. 1 to 2 square root of the x squared plus 1 over 4x squared squared, and then the x. So we can cancel out the square root. But not over yet, we still have the integral. So we have the x squared plus 1 over 4x squared, and then the x. Well, maybe it's safer to write with absolute value. The conclusion is still the same, but it's, I think, much safer. But I think I can go just normal bracket because it's a positive functions, right? You cannot get any negative result inside, right? So you can just directly conclude that this is the functions. I think we can integrate easily. We can integrate easily and make the x squared become 1 over 3 x cubed, and 1 over 4 x squared is going back to 1 over x, right? With negative. So negative 1 over 4 x from 1 to 2. So 8 over 3 minus 1 over 8 minus 1 over 3 minus 1 over 4, right? Okay, what is that?
Not 1 over 2.
Hmm?
X. 1 over 2 x.
1 over 2.
Which
one? Really? I think you could try. If we differentiate this, we will go with this, right? Right. Yeah. Sometimes if you want to confirm, you can check. Right? You can check the derivative. So is it correct? You can try to derive this, whether it's going back to this or not. Okay? That's one way to check. So let's finish this. think this is going to be 24. $64 and 3, right? And this will be 4 and 3, so 1/12. And 61/24. So this will be 224, right? 59, right? Yeah. So 59/24. Okay. Okay. One last part for our class today is still in arc length, but we call it arc length function. So basically what arc length function is basically an arc length, but we define the arc length with a variable x. Okay, if you would like to take notes, you can write first. And after this, we go to the arc length function, and that's it. That's the whole arc length. Arc length functions. And the second part for the chapter 8 is the area, the surface area resolution. It's basically if we remember, we are usually, when we integrate, and if you remember the last part in calculus 1, especially chapter 6, aside from the area, we also compute the volume, right? The volume. Now, in chapter 8, we are not only compute the volume, but the surface area. So if you remember, if we have the curve, and then we rotate, we find the volume, right? But now, we rotate, but find this surface area, okay, along this curve when we rotate. That's the I think for tomorrow's class, okay? Okay, I think I will continue for the arc length functions, last part for today. Arc length function. So if curve C has equation y equal f of x, and then the range is from A to B in the x-axis, and let we define S, okay, as a distance along C from initial point, like let's say we say P0 or P naughts from A, f of A, to some point, let's say Q, and we define Q, the point is invariable in X. So the arc length, we say the arc length function is going to be S of X. Same thing with what we did in arc length, but we are going to define not B, but another variable X. And we need to distinguish the variable, and we need to have another variable for the integration inside here. Let's say we have t, and we have dt. And because I believe this formulations, okay, if you remember, when we have integration from a constant to a variable, if you remember, I think in chapter 5 in calculus 1, when we have this, in the fundamental theorem of calculus, when we differentiate this, okay, when we differentiate. So we derive. So let me write. So by fundamental theorem of calculus, this is equal to s prime x, or ds over dx. We get to remove the integral notes, and we say that we change all the variable t into variable x, right? And we can also write the arc length functions in terms of differentials. We can write ds dx like that, or in dy. So if we want to, let's say, take some illustration here. Let's say that is our graph, y equal f of x. And let's say this is our P0 and this is our Q. Okay. So this is A, this is Q, this is x. Okay. So this is f of a, this is f of x. I think if you define y equal f of x, this will be confusing, so I will remove that. So I will say that this part here, so along the curve, there will be one segment that we define as s of x. So the arc length, the segment of the arc length is a function. Okay? That's what we are going to see here. Okay? So we call this an arc length function. So that means x can be in any points. It's variable. And actually, from these arc length functions, we could get the previous approach for the hypotenuse formulation.
Does it mean that the arc length function is how the length increase with the text? How the length increase with text as an increase text?
Yeah, of course, yeah. You could think like that. Yeah.
It's the same. Oh, yeah, it's switch. Yeah, it's one.
I think if you read your textbook, sometimes if they ask some approximation, they will like asking the Simpson rule and so on. We can skip that, okay, because I think we don't have time to get to know the sum of approximation formula. Okay, maybe give you one example. Uh, Okay, maybe one example for today. I'm asking here. Find arc length function. And maybe this is also, we can have like some review also for calculus 1. For the curve y equals sine inverse x plus square root of 1 minus x squared with starting point 0, 1. I think this is also direct questions, but I think it's good for reviewing calculus 1, right? Okay, this sign here is the arc sine. Okay, this is arc sine or sine inverse, not 1 over sine. Okay, this is not 1 over sine. Just to remind you. Okay, the sine inverse plus square root of 1 minus x squared. So first thing, same as usual, finding arc length, finding the derivative. Okay. I hope still remember the derivative. But if not, what will you do? If you don't remember what is sine inverse x?
One over.
Yeah, the triangle. Yeah, triangle. Yeah. Sometimes I also forget how to use this. So let the angle becomes let's say theta, like that, right? So let theta. So if we take y equals sine inverse x, then x is sine y, right? So let's just directly say that this is y, the angle, right? Okay. So the sine is what? X over 1, right? So the other part here is, okay. And then with some calculus techniques, we say that okay, we can differentiate using implicit differentiations, right? Yeah, a little bit review. Okay, so 1 sine, what is the derivative? Cosine. But don't forget that we have y, so we write dy over dx. So dy over dx is 1 over cosine y. What is cosine y? Cosine y is this, right? So 1 over cosine y is, we can write here that dy over dx is 1 over square root of 1 minus x squared, okay? But if you remember, you can conclude directly here, okay, to get the derivative of sine inverse. But if you forget, and I believe that is pretty natural, you can go back through here. Okay? Go back through the triangle, define what is inverse means. Okay? Okay, that is for sine inverse. What about the square root of 1 over 1 minus x squared? I think we can derive easily, right? We make half, and then we can differentiate, right? So we can differentiate also for maybe directly write 1 minus x squared half, right? So we could have half 1 minus x squared, and then what else? This is become minus, right? Minus 1 is minus half, and then multiply with negative 2x. Okay. And this will be, we can cancel that, and we have, okay, the same denominator with this, so I think we can simplify this y here. Okay. Oh, I think I'm using y here. Should be using different variable. Let's just change the question. Change the variable, I mean. So that you are not confusing. Let's change to g. Because I already write y here. Okay. So dg over dy, not dy, dx is 1 over square root 1 minus x squared minus x, or maybe directly we can just write minus x like that. And if we take this squared here, take squared, and then plus 1, wow, this will be long. So I think we could write this 1 minus x squared so 1 minus 2x plus x squared and then we need to write we need to plus 1, right? Plus 1. So we need to take plus on the denominator again, right? So plus 1 minus x squared. Right? So this will be cancelled. So we have I don't have space, so let me just drag this and move a little bit here. Okay. So this will be 2 minus 2x over 1 minus x squared, right? I think we can make it this, right? And then this will be 1 plus x, 1 minus x, cancel. Okay, it's going to be 2 over 1 plus x, very little, sorry. Okay, I think we can make it more clear on this side here. Okay. But this is not yet over. We are going to square root this and write in the arc length function. So we are going to have the arc length function. I think we can use blue color. So as x is integration from 0 to x, because its starting point is 0, 1, and this will be 1 plus it's supposed to be the g prime t squared, right? Square root let me write here. Okay, and then dt, and then solve the 2 over 1 plus x. So this whole thing here will be written as two over 1 plus t I think you can solve it, right? To start, do over 1 plus t. Right. Integrate.
Oh, sorry.
Why?
This
Why
one?
this part can cancel?
Oh, because of this.
Okay.
Right. Okay. Okay, I think that will conclude our class today. So yeah, see you tomorrow, right? Yeah, tomorrow we have another class and we can continue.